So I do believe it's recording. So hello everyone. My name is Amrit and welcome back to this Learning Python from Scratch course or webinar series. If you are watching on YouTube, do note that these webinars take place Monday to Friday at 1 o'clock UK time, so GMT. If you do have any questions, if you're watching on YouTube and you do have any questions, the best way to get them answered is probably either, of course, number one being Google, search them online, it's computer science. There's pretty much everything online for this topic. But if you can't find any solutions or answers online, you could always you could always show up on our live webinars and ask questions in the chat. Which reminds me, I forgot to put chat up today. So there we go. I have chat up. So if you do have any questions, you can post them in chat and I will see. That being said, today is the 11th session, 11th day. Today, yesterday, if you haven't seen yesterday's webinar, we went over recursion. Recursion can be fairly powerful, but it does have its downsides, that it's very memory intensive, but other than that, it can be very powerful, and it could be fairly easy to program too. Let's just double check I'm using the right mics. Yep, cool, everything should be good. Now let's share my screen. Yes, okay. There we go. Let's put that to the side. And let's pull up the challenge I gave yesterday. So yesterday I gave you this challenge to do recursively. Now, the way I did my answer, I did it in a way that I haven't taught one of the things in this webinar series, but I'll quickly go over it today. But yes, by no means is this easy. This is a very difficult challenge. This by far would probably one of the hardest challenges I will be giving. But the entire idea of this challenge is you have to make this kind of calculator where you give statements in a funny way. It calculates it depending on these rules up here, and it gives you the answer. So the entire gist of this was you can't use loops and you have to do this recursively. Now, the entire point of doing it recursively is just to practice it. We want the shell up and we want this up. Cool. So the entire point was so that you could learn how to do it recursively, and yeah, so it's fairly straightforward. Now, my code for this isn't that long. It's roughly 59 lines, which all things considered is not that long at all. But let's kind of get into how I went about doing this. So just the basic gist of it, we have 15 numbers, 0 to 15. And you could do kind of three things with the numbers. If you see a plus, if the leftmost is a plus, you basically add the next digit to the rest, to the calculation result of the rest. So since we have a +2 here, well, this is going to be 2 plus whatever this resolves to. The second thing you could have is sum. So if you see an S, you basically sum everything to its right. In the sense that so let's say you do sum of 5, you do 5 plus 4 plus 3 plus 2 plus 1. So sum is in from 1 to that number. That's what sum does. And the last thing is just straightforward, a digit. So it could be just F, and you should be able to run 15. Of course, this is hexadecimal, so you go from 0 to 15. So A has a value of 10, B is 11, C is 12, D is 13, E is 14, F is 15. So those are the main three things you could do in this calculator. And of course, you kind of write out the expressions like that. Now, the way I've done it is fairly straightforward, but we'll go down method by method and then the last thing. So the way I've done it is assuming that the user enters a correct statement, a statement that can be calculated. Now this, you can have assumed that and done it that way, that's perfectly fine. This program didn't specify that if you enter something correct, it needs to do something, but I've added the extra functionality that if the user enters something incorrect, that the program responds accordingly. That was kind of optional. Anything above what the base level says is optional, but I have done a little bit extra just so the program is harder to break. That being said, so the first method I have is the main recursive method, and this basically just determines how we continue on. So in yesterday's webinar, I kind of did give you a hint where in a string, the same way as an array, you could access a specific character by giving the square brackets and what character you want to access. So this is fairly straightforward. So if you give it this first char, I could probably change the name to something more relevant and better. But if you give it an expression, so by expression, of course, mean one of these, what it then does is it gets the first character in this expression, so in this case it would be plus, in this case it would be an S, in this case it would be F. It gets the first character and just stores in this variable char1. Now if this first character is a plus, what you do is you return the second character, so the thing with plus is the second character has to be a digit. No matter what, you can't do plus sum, that's not allowed. You have to do plus a digit. So you return as a, so I have a method as digit that we'll get into in a second. As digit, the second character, remember as computer science, start counting from 0, not 1. So this is the first character in the string, this is the second character in the string. So if the first character is a plus, what you end up doing is you take the second character, you kind of turn it into a digit, and you add it to the rest of the expression calculated, basically. So this I didn't teach yesterday, but I did teach in the arrays webinar session. So this is a possibility. So if you want a string from a certain point onwards, you use this method to kind of do that. If you want to get, let's say, from this character onwards, you specify what position. So of course it's 0, 1. This is the second position. So you go from the second position onwards till the end, and this kind of just returns that. So you calculate from this position all the way to this position. So calculate all of that. So this should kind of, so far, start making sense into how I've done it. So you return the second digit plus the rest of the expression calculated. We don't care how it calculates it, we just want it calculated. And then we add it to whatever digit we had. If it's an S, if the leftmost character is an S, what we end up doing is returning the sum of the first, same thing as over here, the rest of the expression calculated. Instead of 2, we have 1, because of course with S we don't care what, we don't have a specific digit, so we just get the next character and go onwards. Sum is a function in Python, so if I get rid of this, it turns purple. I advise against, for this exercise specifically, of using that sum method, and to make your own recursively without any loops. So hence I've also created my own sum off method, which we'll get into in a sec. And the last thing is, if it isn't a plus or an S, it has to be a digit, assuming that whatever the user entered is valid. And then we just do as digit and send back whatever the user enters. I have set it to 0. Technically, I can get rid of this entire thing. But the reason I've done this is, let's say like the user accidentally entered an extra number over here. This will only take the first thing and return that. So it kind of fixes, I guess, what the user enters. But technically speaking, I should have done it like that. But for now, this is perfectly fine. Now, sum of I also did recursively. Of course, sum of is just, if you give it a number, it wants to do 1 plus 2 plus 3 plus 4 all the way up to that number. So 1 plus 2 plus 3 all the way up to x. So this is our base case. Of course, let's go back up here. If we were to talk in the sense of base cases and step cases, this is a base case. This is where we start returning everything. And these are our step cases because they still keep calling itself until we get just to a single digit. So these two are step cases, and this is our base case. In yesterday's webinar, we looked at how to do factorials and recursively, and we also had one base case and one step case in that. This is pretty much the exact same to the factorial method I showed you yesterday, that how to do factorials recursively. The only difference being instead of times, we're adding them. And yeah, everything else is the same here. So if you don't fully understand this, go check out yesterday's webinar. And this is a very, I won't say complicated, it's just a really straightforward method. Just compare, so if what the user, like if we are evaluating one digit, just check what it is, check it in string form. So we want to check if it, what string it is, so if it's A, B, C, D, E, F, or if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. Oh, I forgot 0. Oh, I guess I forgot one. Let's quickly add it in. If x equals 0, 0 is also one of the numbers we had to do. Return 0. So basically, the entire idea of this is check what string it is and return its corresponding number. Really straightforward. I couldn't think of a shorter way of doing it. No, there is a shorter way of doing it line-wise that I just thought of, but this is perfectly fine too. And then we get to the main part of the code. So hopefully all of this so far should make sense. And this is where I use something that I haven't gone through yet, but I'll go through now. So this should be fairly straightforward. Expression is equal to input. Please enter the expression. Please input the expression. Same thing. Doesn't really matter what the text is as long as it functions the same way. But yes, this should be fairly straightforward. What this does, I believe we went through this in our third webinar. So to go back if you're not sure. But this is a very handy thing in pretty much most programming languages called try and catch or try and accept. You have to, depending on your programming language, you kind of have to look up what the exact syntax is. Syntax just being the exact wording or the exact way you have to do in a programming language. In Python, it's called try and accept. And the entire idea is try doing this piece of code. And if it doesn't work, if it gives you an error, then run this piece of code. So try and accept is a really useful. In previous lectures or previous webinars, I have been saying that most of our codes will easily break if you needed to enter a number and user enters 20 in words and letters. A really easy way of fixing that is try converting it to an integer, so using a try and accept. Try converting an integer. If that gives you an error, accept could just be ask again. Ask the user until they enter something which is valid. So you could have try and accept in a while loop, and while the user doesn't enter something which is valid, keep asking them to keep trying to turn into an integer, otherwise do something else. So try and accept is really useful. Except you could also specify what type of error. So if you get this type of error, do this. If you get this type of error, do that. If you don't do anything, it will just be generic. So if you do get an error, do this. So the entire idea here is if the user enters something which isn't correct, which will break this in one way or the other. Let's say that it doesn't, the user enters like, I don't know, like Z. Of course, this can't compute Z. So eventually, one of the returns or something's going to cause an error. And this try will catch it. And then the accept will run saying the expression is not valid. Of course, this isn't compulsory, but this is a really easy way of doing it. So if we run this, let's load back the image. There we go. So let's enter the bottom two expressions. So let's start off with the second last one. So s plus 2 plus 1 s2. There you go, answer is 21. So it definitely works. Let's run it one more time. Run module. Okay. There we go. So plus 2 plus 3 plus a 5. There you go, answer is 20. So essentially how this works is, I'll just explain the bottom one. So 2, so of course we see the plus, so 2 plus all of this, then it's 3 plus all of this, and it's a plus 5. So 5 plus a which is 10, so that's 15, plus 3, which is 18, plus 2, which is 20, so that's fine. So hopefully this makes sense. You can rewatch this section if you missed anything. But that being said, hopefully this makes sense, and do leave any questions in chat if you do have any. Let's close this up. Now let's get into today's the bulk of today's topics or discussion, what we'll be going through, which is sorting algorithms. Now, it's kind of weird why I'm going through this, and the main reason why is to give you an understanding of how things work in computer science, and just for more practice with the basic concepts we've been going through. Talking about more practice, I now have these big challenges. These big challenges are, I say massive in quotes, massive programs that will require a fair bit of, which will require a fair bit of time to do. I guess it all depends on your level of programming, but these are big programs that will require a lot more thought than the little programs. These big programs combine everything we've done so far, yeah, so these programs will require you to use pretty much everything we've done so far, and in order to complete to the standards or to the criteria the program set. I have a fair few of these, so for the next few webinars, I'll be giving you one just before we start the topics. The answer to these, if I were to give the answer to the previous one at the beginning of every webinar, it may take a while. So the answer to these may be as a link in the description of these webinars as YouTube videos. I will have to see how I would do this. If not, if I can't do that, then I will probably just quickly scan through it in the beginning of each webinar. But these are big tasks. These require you to use everything we've done, so abstract data types, while loops, for loops, arrays, if statements, inputs, outputs, you name it, you kind of have to do it in one way or the other in this program. That being said, it shouldn't be too difficult, and this is purely for practice. These are practice programs for you to do, and if you could do them consistently, you'll just keep getting better and better. So I highly advise you do these. And yeah, so if you're on YouTube right now, take a screenshot or pause it. You could take a go. Or if you're watching it live, take a screenshot, and you should be good to go. That being said, I'm going to leave this on for a few more seconds while I talk. That being said, today we will be going over what we call sorting algorithms in Python. Well, sorting algorithms in general, and we're going to be learning how to implement them in Python. Now, first questions first, why do we need sorting algorithms? Now, consider this. Let's say you're a business and you use an array to store, I guess you use an array to store information on people. So let's say the age of X amount of people. You have an array and you store the ages of said people for whatever reason. Now with arrays, by default in Python and most other programming languages, when you want to get an access, if you look for something in an array, you use what we call linear search. We'll get into that in a second. But the problem with that is if you have, let's say, 100 or 1,000, 100 or 1,000, let's say, entries in this array, all of a sudden linear search becomes very slow and very inefficient, and there are other methods out there to look for stuff within arrays. Now, look, we will go over searching algorithms in a future webinar. I'm not sure how many webinars this may take. If anything, I doubt we'll be able to go through everything I want to in one webinar, so there may be a part 2 to this webinar, which will be Monday's webinar. Depends how much we go through today in the next 20 to 30 minutes. That being said, yeah, so the reason we're going through sorting algorithms first is because for a lot of the searching algorithms, your array needs to be sorted in a given way, which is why it just makes sense to do sorting before searching. And yeah, so I'm gonna get rid of this now, and we're gonna kind of discuss some of the sorting algorithms. Let's open up this whiteboard and let's discuss. So I will be going through how to implement them in Python, but first it just makes sense to kind of understand them and go through them on pen and paper. So by default, a lot of programming languages use linear search. Now let's kind of discuss what linear search is, and the problems with it will become apparent when we go through it. Of course, linear search is a search algorithm, I know, but I'm just discussing that, so sorting algorithms just make more sense. So let's say you have an array. This is your array, and we normally depict arrays as a big rectangle split into boxes. Let's populate this array. So let's see, 5, 15, 6, 4, 12, 20, 4, let's say 4 again, yeah, and 1. Let's say this is the array. This is how the data was entered for whatever reason, and this is what your array is. Now let's say you want to look for the number 12. So what most programming languages do is you start here. Of course, as a human, you know what 12 is. 12's right there. It's obvious as a human, but as a computer, you don't know what 12 is. The way you figure out where 12 is, or even if you have 12, maybe you don't have 12. So the way a computer does it is you go to the first location, check if that's 12. No, that's not 12. Then you go to the next location. Is that 12? Nope. Next location. Nope, that's not 12. Next location. Nope, that's not 12. There we go. We found 12, and then we give you this position. So of course, there's a position 0, 1, 2, 3, 4. So computer returns 4 to you. That's all well and good. And for small arrays, computers could do it really quickly. For arrays up to, I guess, 100, 200, with 200 elements inside of it, computers could do it fairly quickly. Now, let's say you have an array with 1,000, 2,000, 3,000 entries in it. All of a sudden, linear search becomes very, very slow. There are searching algorithms that could give you whatever you're looking for very quickly. But as I said earlier, in order for them to work, your array needs to be sorted. And by sorted, I mean from smallest to biggest, biggest to smallest. Those are generally the two most used ones, smallest to biggest being the most used one, and that's the way we'll be kind of looking at it. But turning a smallest to biggest sorting algorithm to biggest to smallest will only require you to tweak like 1 or 2 lines. That being said, let's look at the first sorting algorithm that we will be kind of learning to program, which is bubble sort. Let's move that down. Cool. So bubble sort kind of gets its name from the way the sorting algorithm works. So bubble sort. There we go. So bubble sort kind of gets its name from the way the algorithm works, in the sense that it looks like bubbles going down the array. So bubble sort is fairly straightforward. Let's create ourselves an array that needs to be sorted. That was a terrible line, but we'll go with it. 1, 2, 3, 4, 5, 6. Cool. Let's populate it. So random numbers. Let's go 5, 12, 1, 4, 6. Let's go high 15 and 4. I go 4 a lot. Let's go 14. Let's say this is our array. Bubble sort works in a fairly simple way. In order to be in from smallest to biggest. So is this element bigger than this element? In this case, it isn't, so we don't do anything. So first we compare these two. Since this is smaller, we don't do anything. Then we